ABCD is a parallelogram, and points I, J, K and L are midpoints of the line segments AB, BC, CD and DA respectively. Find the coordinates of point C in each of the following coordinate plane configurations. The coordinate plane ABD, the coordinate plane CDB, the coordinate plane LJD, and the coordinate plane AIL. Since ABCD is a parallelogram, we are dealing with an oblique coordinate system. And as such, all four coordinate planes we are asked to consider are oblique. We know this since the x and y axes of each plane are not perpendicular. In the first part of the question, we are asked to consider the coordinate plane ABD. When the coordinate plane is written using this notation, the first letter corresponds to the origin. This means that point A has coordinates 0, 0. The second letter means that AB is the x-axis, with line segment AB its unit length. In this coordinate plane, point B has coordinates 1, 0. In the same way, line AD is the y-axis, with the line segment AD its unit length. This means that D has coordinates 0, 1. Since the angle DAB is not equal to 90 degrees, this confirms we are dealing with an oblique coordinate plane. In each part of this question, we need to find the coordinates of point C. To find the x-coordinate, we look for a line parallel to the y-axis that passes through point C. This is the line BC, and as it intersects the x-axis at point B, we know that the x-coordinate of C is 1. We can then repeat this process to find the y-coordinate of point C. We look for a line parallel to the x-axis that passes through point C. This is the line DC, and it intersects the y-axis at point D. We can therefore conclude that point C has coordinates 1, 1. If the coordinate plane is ABD, then point C has coordinates 1, 1. In the second part to this question, we need to consider the coordinate plane CDB. This time, point C is the origin, and as such, we don't require any further information to conclude that in the coordinate plane CDB, point C has coordinates 0, 0. Next, we need to consider the coordinate plane LJD. This time, the origin is at point L. The line LJ is the x-axis, with line segment LJ its unit length. This means that J has coordinates 1, 0. LD is the y-axis, with line segment LD its unit length, and D therefore has coordinates 0, 1. Repeating the process from the first part of this question, we see that line JC is parallel to the y-axis and intersects the x-axis at point J. Likewise, line DC is parallel to the x-axis, and this intersects the y-axis at point D. Point C is therefore 1 unit in the x direction and 1 unit in the y direction. And we can conclude that in the oblique coordinate plane LJD, point C has coordinates 1, 1. Let's now consider the final part of this question. This time we have the coordinate plane AIL. As with the first part of this question, the origin lies at point A, so A has coordinates 0, 0. Line AI is the x-axis, With line segment AI its unit length, and I therefore has coordinates 1, 0. Point L has coordinates 0, 1, as AL is the y-axis and the line segment AL is its unit length. Since points I and L are the midpoints of the line segments AB and DA respectively, we know that in this oblique coordinate plane, point B has coordinates 2, 0, and point D has coordinates 0, 2. We can then draw lines parallel to the x and y axes that pass through point C once again. As these lines intersect both the x and y axis at 2, we can conclude that point C has coordinates 2, 2. We now have answers to all 4 parts of this question. Point C has coordinates 1, 1, 0, 0, 1, 1 and 2, 2 in the 4 given oblique coordinate planes.